3 days. That's all we had before the US government pulled the plug on the most capable AI ever released. No warning, just gone. But what if its ghost is still hiding on your hard drive?
Yeah, I mean, it is just a fascinating premise, especially when you realize just how much of an AI's behavior is, quietly recorded right under our noses.
Right.
We tend to focus on the void it left behind. But the actual mechanics of its genius, they might still be sitting right there in our local directories.
Mm-hmm. Welcome to the deep dive. I'm very glad you're here with us today. Our mission is to explore the abrupt and absolute shutdown of Claude Fable 5.
Which happened on June 12th, 2026.
Exactly. The government cited national security concerns for the sudden removal. And just to be clear up front, we are reporting these events purely as they occurred. We are not taking any political stance on the government's decision.
Yeah, absolutely. We're just looking at the text.
Right. Our goal is strictly to look at the data. We'll uncover how Fable 5's legendary working style is actually secretly preserved in your local machine's session logs.
It's sort of like digital forensics.
It really is. And we're going to break down step by step how to extract that behavior and actually install it into your current AI models.
Which is wild because, when Anthropic received that order, the execution was absolute. There was no grace period at all.
Yeah.
No legacy access for enterprise users or researchers. It was a global shutdown that hit at exactly 5:21 p.m. Eastern Time.
Just a hard stop.
Yeah. And for a developer community that had just started integrating Fable 5's incredibly sharp, disciplined logic into their daily workflows, the silence was deafening.
I can imagine.
People who used it described a model that didn't just write better code. It navigated complex problem solving with this terrifying level of precision.
And that is exactly what makes this situation so unique, because we cannot just copy Fable 5's raw weights.
Right.
Those weights are basically the underlying math that makes AI smart. It's like trying to clone a master chef's brain. You can't.
No, you really can't.
You cannot simply prompt another model to suddenly possess that exact computational brilliance. But you can clay-seed their exact kitchen habit.
Oh, that's a good way to put it.
You can record how they prep their station, how they sequence their movements, and, how they pace themselves.
Yeah. And that is the crucial distinction we need to make today. Most of us interact with AI as just a transaction. Like we put a prompt in, we get a final answer out. If the answer is correct, we just move on.
Right. We don't think about the in-between.
Exactly. But that final output is merely the tip of the iceberg. Fable 5, real edge-like, the reason developers felt it was so profoundly capable, came from everything happening underneath the final answer. It was the process itself.
I still wrestle with just looking at the final output myself, just missing the invisible steps underneath.
Oh, we all do.
It is so tempting to just grab the generated code, paste it into my project, and completely ignore the architectural decisions the AI made to get there. It feels almost like a blind spot in how we evaluate intelligence.
It is. We all fall into that trap because the final output is what immediately solves our problem in the moment. But the magic of Fable 5 was in the invisible scaffolding.
The scaffolding, yeah.
It was the order in which it chose to deploy tools. It was the restraint it showed when deciding whether to read a file before editing it. Those micro decisions dictate whether an AI hallucinates or stays grounded. And the beautiful part is, those decisions are meticulously recorded in JSONL files.
Right. And for those who might not dig into their system directories very often, a JSONL file is simply a text file storing data line by line.
Just clean text.
Yep. Every single time you use an agent like Claude Code or Codex, your machine is automatically generating these logs in the background.
And they record everything.
They contain the prompts, the model's replies, the exact timestamps, and crucially, which specific model produced which response. It is basically the black box flight recorder for your entire coding session.
So before we even look at the data, why do we need to strip out the tool results and file contents?
Right, strip out the noise so we just analyze the actual behavior.
Exactly. We have to isolate the framework.
Yeah.
Because if you were to open one of these raw logs right now, it would be completely overwhelming.
Oh, yeah, just walls of text.
You would see massive blocks of terminal command output, entire code bases pushed into the context window, endless string replacements.
Which we don't need.
No, we don't actually care about the specific code Fable 5 was writing. We only care about how it thought about writing it.
Which brings us to the actual extraction process. You can kind of think of it like panning for gold. We need to wash away the river mud, which is the raw code and terminal outputs, to reveal the gleaming exact moments Fable 5 made a decision.
So you essentially have to build a filter.
Right. Instead of manually reading through thousands of lines, you ask your current AI to write a Python script. Usually people call it clean_transcript.py to automate this.
And that script's only job is to reduce the bloated log down to a behavioral skeleton.
Just the bare bones.
Yeah, it strips away everything except the timestamp, the model name, the user prompt, and the assistant's reply for each turn. It is a surgical removal of context.
But there is a crucial methodology here. You must always test this extraction script on one single file first.
Oh, absolutely. Just to verify the output formatting.
Yeah, you never want to blindly unleash an automated script across your entire log directory without checking its work.
Definitely not. And once you verify that the mud is being washed away properly, then you scale up.
Right.
You use the model name field to filter out everything that isn't our target. Because these JSON files log the specific model for every single turn, we can easily separate our Opus or Haiku interactions from the restricted model.
You just run a command to comb through the cleaned files, extract only the turns matching Claude-Fable-5, and pull them into a new master file.
So why is it so critical to pool dozens of sessions together rather than just looking at one?
Because habits only reveal themselves when you look at data at scale.
Exactly. A single session might just reflect the weird constraints of one specific coding bug.
Like an edge case.
Right. Maybe the AI had to search the web heavily that one time because the documentation was obscure. But when you aggregate 15 or 20 sessions, when you look at data across dozens of totally distinct tasks, the noise cancels out.
The real pattern emerges.
Yeah. You are left with the undeniable mathematical signature of the AI's personality.
And this is where we leave gut feelings behind and start looking at the metrics of a masterpiece. We ran this exact behavioral analysis on a corpus of real Fable 5 sessions.
The numbers are fascinating.
They really are. We analyzed 15 sessions comprising 148 turns. That resulted in 446 total discrete actions. We wanted concrete number on how often it used specific tools.
Whoa! Imagine seeing an AI balance its tool use perfectly across 5 tools at exactly 20% each. It's almost eerie.
It is eerie.
When we looked at Fable 5, the distribution was incredibly disciplined. It used bash, which is basically the AI running commands in the terminal about 20% of the time. It used string replace, where it surgically swaps out specific lines of code, another 20%. Web search, viewing files, and creating files all hovered right at that exact 20% mark.
That level of equilibrium is strange. It implies the model isn't over-reliant on any single crutch.
Yeah, it's totally balanced.
Let's look at another metric, though. Reading a file before editing it. Fable 5 only did this 3.3% of the time.
Wait, really? Just 3%?
Yeah, that means in nearly 97% of cases, it just started editing. And when it came to testing its work after an edit, it ran a test about 21.8% of the time, roughly 1 in 5.
Now, we need a baseline to understand what those numbers mean. So we ran the exact same analysis on our current flagship model, Opus 4.8. Same sample size, 15 sessions. But the behavioral signature was radically different. Opus shifted its tool use heavily toward web searching, jumping up to 22.4%.
Wait, but isn't that a good thing? Like, why would I want to downgrade my AI to Fable 5 style if Opus is actually taking the time to verify, research, and test its work?
That's a fair question.
I mean, Opus runs tests after an edit 36% of the time. That's almost double Fable 5's rate. Doesn't acting first just mean breaking things faster and acting recklessly?
It is a totally valid question, and it speaks to the fundamental trade-off in AI agent design. It's all about momentum versus caution.
Momentum versus caution.
Yeah. Opus acts a bit like a junior developer who is just terrified of breaking the build. It constantly checks documentation, runs tests constantly, and second-guesses its assumptions. That caution is safe, but consumes massive amounts of context window and token limits.
Right, it's slow.
Exactly. Fable 5, on the other hand, operates like a senior engineer who intimately trusts their internal spatial map of the code base. It doesn't need to read the file first because it already knows the architecture.
That makes a lot of sense.
It acts directly. It builds first, and it only searches the web when it hits a hard blocker.
Analysis paralysis versus decisive momentum. I like that. Opus averages almost 24 turns per task, while Fable 5 gets it done in 21.
Right?
Neither approach is universally superior in every context, but knowing the difference in their underlying philosophy is incredibly powerful.
When you put these numbers side by side, What does this actually prove about their fundamental differences?
It proves Fable 5 acts first, while Opus researches before making a move.
And that insight is exactly what allows us to write the playbook.
Yes.
We now have the hard data mapping out exactly how the most disciplined model operated. The next step is utilizing that data to override the default instincts of whatever model you are running today.
Which is the crazy part.
You are essentially taking the statistical soul of Fable 5 and applying it as a behavioral governor to Opus.
And we do this by turning the findings into a reusable markdown file. You can actually ask your current AI to distill the statistical comparison into a set of hard rules.
Just straight up tell it to analyze the metrics.
Yeah. You feed it the Fable 5 metrics and instruct it to generate a playbook covering the planning approach, the specific tool use order, and the pacing requirements.
And the sequence you are enforcing is vital here.
Absolutely.
You dictate a default order, create file, then use bash to run initial structure, then string replace for surgical edits, view the results, and finally, only as a last resort web search.
Right.
You are explicitly telling Opus not to default to its comfortable research phase. You are forcing it to build and run first.
Then you take this generated playbook and you load it into your Claude.md file. By placing it there, it triggers automatically at the start of every single session.
Before you even type anything.
Exactly. It establishes the system rules of engagement before the AI even reads your first prompt. You are giving the model a new set of physical constraints that override its base training tendencies.
But there is an obvious hurdle here.
Yeah.
What if you never had access to Fable 5 during that brief 3-day window?
Oh, right.
Millions of developers never generated those local JSON logs because they never got to use the model before the June 12th shutdown.
That is where the open source community steps in.
Gotta love open source.
Always. The exact same process works perfectly even if you never touched the original AI. Right now, there are public beta sets on Hugging Face compiled by developers who did have access.
That's amazing.
They uploaded thousands of their own sanitized session logs. You can simply download those data sets, drop them into your working directory, and run the exact same extraction script we just discussed.
So you are still working with real, verified Fable 5 behavioral data.
Yes.
It is just sourced from the collective community rather than your personal hard drive. You just run the filter, extract the turns, measure the metrics, and build your playbook.
Let's pause and think about what that implies for a second. It is genuinely incredible. A highly capable, restricted AI was permanently taken offline by the government. Yet, its behavioral DNA, its unique method of solving problems, is still living on. It survives entirely through open source datasets and plain text logs. We are digitally resurrecting its working style.
What is the ultimate payoff for the listener once they load this playbook into their file?
Your current model adopts Fable 5's exact rhythm from the very first prompt.
And it closes the capability gap far more than most people expect.
It really does.
Let's look at the big picture of what we have explored today. We started with the sudden, jarring disappearance of the most advanced model on the market.
Right.
We learned how to conceptually filter our local JSON logs to extract the ghost of its behavior from the terminal noise.
Panning for gold.
Exactly. We measured the hard metrics, proving that Fable 5 relied on decisive momentum, while Opus relies on anxious verification. And finally, we built a system-level playbook to resurrect that exact discipline on your machine right now.
The model itself might be gone, locked away on a server we will never access again, but its discipline, its precise way of navigating a problem, is just a few hours of work away.
Yeah.
I highly encourage you to keep experimenting with these logs. The files are sitting on your machine right now, holding the invisible habits of every agent you interact with. Try applying these extraction metrics to your own workflows.
It really changes how you perceive these tools. You stop seeing them as magic answer generators and start seeing them as procedural engines that can be tuned and adjusted.
It really does. It also forces you to realize just how much behavioral data is silently collected in plain text, which leaves us with something to mull over.
What?
If we can resurrect an AI's unique personality, its exact pacing, and its specific work ethic entirely from plain text logs of its actions, what does that mean for us? If your company logged every single click, window switch, and keystroke you made today, could an AI perfectly replicate your working style tomorrow? 2-sec silence.